Hey, Walter Sorrells back with more tips for the knife maker. Today, making it flat. Flatness, squareness. So first, why do we care? And second, how do we get there? Now, I'm going to tell you right up front that for serious knife makers, these two subjects are right up there with metallurgy in importance in terms of making good knives. But also, I'm going to warn you, nerd alert here, I'm really going to be drilling down into this subject in a lot of detail. So if you're that guy who just wants to watch, big flames and hammers and all that kind of stuff, this ain't that video. I've got plenty that are, but not this one. One quick note, this video turned out to be pretty long, so I'm breaking it into two parts. The first part is going to address just flatness, and then the second one, squareness or perpendicularity, we'll get in a second video that'll follow in the next week or so. So let's get into the why of the subject. I did a Friday 5 video a while back about flatness, but I got a note from Dan Lawson, who's one of my Patreon supporters and was a recent student in a class that I taught down in Florida. And he wanted me to just kind of go a little further with the whole subject of flatness. So that's what we're doing today. First, let's dig into the who gives a damnness of the subject. So first, just kind of definitions. Flatness means how much does a piece of material deviate from some, theoretical perfect plane? And by square, what I mean is perpendicularity. In other words, how close is something to a perfect 90-degree angle? Okay, so why is flatness important to knife makers? Well, first, if you're making custom knives, you don't want gaps between the handle and the tang or the ricasso or other parts of the knife. So for starters, getting your tang really flat is very important, especially in full tang knives. Now, if there's any deviation in the flatness of either your tang or your handle material, then you're going to get little gaps between those two materials. And this is a big no-no in custom knife making. Not only does it look bad, but it creates opportunity for water or other crap to get in there and cause the knife handle to gap away from the tang and eventually just fall off. So a second point about flatness is that if you're working with any material that's not flat or that's irregular in any way, it's a pain in the neck to fixture and to handle it generally because it just doesn't lay flat in your vise or whatever surfaces that you might want to be working on. So flatness will help you out in a lot of other little tasks prior to actually putting the whole knife together. Additionally, a flat surface can be used as a reference surface for establishing other important features of the knife, like holes or knife scales, folding knife pivots, and so on. Flatness is extremely important in folding knives because if something's not flat, the pivots are not going to work right, just all kinds of stuff will go wrong. All right, so let's get down to brass tacks and actually talk about how to make things flat. Now, the first approach, and I'm really not being funny here, is to just buy it flat in the first place. For instance, steel is generally sold in several different conditions, one of which is straight from the mill, which means you get scale, pitting, irregular surfaces, imprecise thicknesses, potential warping and twisting, just a lot of reasons not to buy it that way, but you can also buy steel in precision ground form. Precision ground means that the steel has been descaled and then run through a surface grinder to a very precise thickness. When it gets to you, it should be dead flat, have precise and consistent thickness, and have at least a reasonably good surface finish, all of which means less work for you. The only trade-off, and it's a big one, precision ground costs quite a bit more than unground mill finish steel. Now, steel is not the only material that can be found in very flat condition. Some materials, like micarta, are generally manufactured quite flat. Others, extrusions, bars of metal like brass and aluminum, they often seem flat and they can kind of fool you. So you need to be very sure about whether something is or isn't flat. Alright, but obviously the harder way, and this is what this video is about, is to make it flat yourself. So before we go any further, let's talk about some of the tools that you can use to verify flatness. If you can't test it or measure it, then you don't really know if something's flat or not. I've got some videos that cover these measuring tools in more detail. Link here if you want to check those out. But quickly here, let's run through some of the tools that will be helpful for you. First, a ruler. High quality machinist rulers are really handy and they don't cost insane amounts of money. And in fact, simple metal rulers that you can buy from Home Depot or places like that are quite effective. See, the simplest way to gauge if something's pretty flat is to set a ruler edgewise on the material, hold it up to the light, and see if you have any gaps that light shines through. This seems kind of simplistic, but it'll detect amazingly small defects, dips, wobbles, things that otherwise are only measurable with pretty sensitive measuring devices. So before you freak out worrying that you're going to have to buy all kinds of expensive tools, recognize that a decent ruler will get you to almost any level of flatness that a beginning knife maker could possibly want. Second device, a machinist square. You can buy these from Shars or Grizzly or eBay all day long for dirt cheap, and they're plenty accurate for normal knife shop work. 3, a pair of cheap electronic calipers. You can buy the $200 Mitutoyos, but you can probably buy these for $30 or so, and they're still quite accurate. They're just not as smooth or as long lasting. Hey guys, let me jump in quickly to mention that if you're enjoying these videos, I hope you'll help the channel on Patreon. Click the card or follow the link down here to see how it works. Now, I try to make a wide range of videos so that no matter where you are in your knife making journey, I've got something that's going to help you. Now, some of these are complicated projects and some use really simple tools and techniques, and some, like this one, are aimed at building your base of skills and your knowledge. Now, one of the things you'll notice about my videos is that you get plenty of detailed close-ups, all kinds of different angles to see what you're doing, good lighting, and let me tell you, if you've done any video, you'll know that this takes just lots and lots of time. That's time that I take away from my family, from making knives, from doing other things that put food on my table. So if you want more videos like this, as well as access to plans of many of my projects, help yourself out by helping the channel. Thanks, and now let's get back to work. Having a reference surface like this granite surface plate is really handy. You can buy the cheaper, smaller ones, which are still very flat. They're handy both for measuring and layout and for abuse, for grinding things on. But more on that later. Dial indicators are really handy. Measuring to 1 thou is what you need for this kind of work. You don't need 10 thousandths for most knife making work. There are two kinds. There's the plunger type and the dial test indicator or flipper probe type. Personally, I use the flipper type way more than the plunger type. To get any use out of a dial indicator, you need a high quality stand. The Noga brand with the articulating arm is super useful. They're Chinese ones that you can buy for like $10, but I don't trust them because they're just not as rigid as the more high quality ones. Plenty of other measuring devices out there, including height gauges, micrometers, depth mics, just endless stuff. But with a ruler, a square, a pair of electronic calipers, and a flat surface, you can accomplish a ton. So let's start talking practical. I'll start with the cheap elbow grease type methods, and then I'll work my way up to more expensive, more machinery heavy kinds of methods. Now, of course, there are all kinds of ways of flattening things using much more expensive equipment, mills, surface grinders, and so on, but we're not going to get into that in this video. In today's video, we're just focusing on techniques that are within the grasp of beginning knife makers. Here's the cheapest way to make something flat. Get a flat surface. Here I'm abusing my machinist surface plate, but a sheet of glass micarta, a faux granite countertop sample from Lowe's. There are a lot of very flat surfaces available on planet Earth, and they'll all work. Don't assume though. Just check it first using the handy dandy light through the rule trick. So, tape on a piece of sandpaper, then start sanding. You can do this with wooden handle scales, steel, bolster material like brass or stainless steel. It all works. The one thing that I'd recommend is that you don't just sand in one direction. Some people like the figure 8, or you can turn it around as you go. Also, move your fingers to different locations. Especially with thinner or softer materials like handle scales, just the pressure of your fingers can cause it to dish out in those locations. If you don't take these kinds of measures, you'll tend to sand unevenly. So you scrub away, and you keep thinking you're making progress, and every time you check it, it looks wrong. So just keep varying what you're doing, the pressure, the angles, and all that, and eventually you'll get pretty flat. A second point, and this is really important, is that I always flatten the blank, not the finished part. Especially with hand methods like this, you'll almost invariably roll the edges of the blank a little bit. So provide some extra room for that waste material so that you leave only super flat areas in the center of your piece of steel or your handle scale or whatever it is that you're trying to flatten, and then you can remove all that extra junk that's not as flat. Alright, let's step up to the next simplest and cheapest method, which is using a disc grinder. Disc grinders are pretty cheap, and flattening's what they do. So they're very handy for the knife maker's shop. Safety note, you always want to grind down on the side of the disc's rotation, or you can chunk your work across the room. Now, there are a bunch of tricks to using disc grinders. First, be aware that they grind harder on the outside of the wheel than the inside. Obviously, the outer part of the disc is moving faster, and therefore it's going to cut faster too. So I like to rotate whatever I'm flattening and move it around a bit. I'll even do this sometimes. Obviously, be careful though, because if you don't seat it right, you can sling the piece across the room. As with all abrasives, heat will build up. You want to dip metal parts in water to speed things up. This is important for two reasons. First, you can cause warping so that you think you got it flat and then it cools down and the piece turns out to not be flat anymore. With plastics, you can actually melt it or create damage to the material. With wood, you can heat it up so much that it'll cause it to crack. So if I'm doing handle scales, for instance, I'll switch from piece to piece, letting them cool as I work. Another point is that no matter how careful you are, you tend to hit the corners as you're pressing it onto the wheel, and you overgrind those. So for the final few grinds, I'll actually put the piece against the disc while it's turned off, then I'll turn it on, I'll grind a little, then turn it off. This way you can maintain 100% contact through the entire grind. Finally, as with sandpaper, if you just push in one spot on the piece, you'll tend to make things uneven, even with hard materials like steel. So I try to move my fingers around and ease up on my pressure as I get close to finishing up. The harder you press, the more you bend the part and dish out the area where you're pushing. It's always a good policy to check the flatness of your work, both longitudinally, laterally, and then corner to corner. Just because you're flat in one dimension doesn't mean that it's right in another dimension. You may have a twist or a bow or something like that you won't pick up by just checking it in one direction. So next we turn to belt grinders. The thing you have to be careful with belt grinders is that it's very easy to make things uneven and actually end up with something that's worse than when you started. If you think you can just stick a piece of steel on the face of your platen and expect to get a consistent flat piece of steel, well, not really. And just going from side to side like this, that is totally not going to get you there. You're going to gouge out little ridges and it'll make a mess of it. So I use this lovely piece of equipment right here that I whipped together many years ago. Basically, you've got magnets inside an aluminum frame and that fits inside wood. The reason for the wood handle is to isolate your hands from the heat. I generally descale the steel like this, working on the corners of the belt. Once you've cut all the way through that scale, then I'll put the steel in my little gizmo and flatten it straight up and down the platen. I move it around a good bit to compensate for uneven belts, uneven pressure, potential low spots on the platen, and so forth. I grind, then I'll flip it over, checking periodically with calipers, flipping top to bottom and side to side to even out my grind. Now honestly, this is a so-so method at best. It works okay in a pinch if you're careful and methodical, but for the amount of time it takes, you're arguably better off just buying precision ground steel. I tend to use this when I'm in the middle of a project and I'm like, oh, I gotta flatten this thing out and I need to do it quickly. Another superior belt grinder approach is to buy a surface grinding attachment. Now, all grinders don't have surface grinder attachments available, but several recent designs like the Travis Wirtz grinder have surface grinder attachments specifically built for them. The way it works is it just runs up and down on the face of your contact wheel. It's not cheap, but it's a lot less than a real surface grinder, and for knife making purposes they get the job done. Of course, the king of flatness is the true surface grinder, which is designed to grind to very, very fine tolerances. If you've already got one, you probably don't need to watch this video. If you really want to do high-end folders, though, a surface grinder is going to be very, very helpful. But for the beginning knife maker, hey, just put that out of your mind for a while. So, to summarize, use really flat surfaces in your shop to make other surfaces flat. Second, flatten the blank before you make the part itself. Always leave a little extra room for the corners to get rolled because those are not going to be as flat as that center section that you want to make your part, your knife, whatever it might be out of. Finally, use simple checks and tools to verify flatness and squareness. So, coming soon, the companion to this video, which will discuss perpendicularity or squareness. We'll include a link in the cards as soon as that video is uploaded. Thanks for watching, guys. If you feel like you got something out of this video, don't forget to subscribe. Also, click on the link to Patreon for a great way to give back to the channel. Plus, check me out on Instagram, Facebook, Twitter. Links in the description. If you want something sharp and pointy, maybe a gift for yourself or one of the cooler people in your life, check out my Tactics Armory website and pick up one of our tactical or outdoor knives. And finally, if you want to learn to make Hamones or Japanese swords, check out WalterSorrellsBlades.com, where you can find videos about how I make Hamones, as well as forging, mounting, polishing, and fittings for Japanese swords. Thanks, and see you soon.